Hey guys, Underwood here, coming at you with another webcast. Today we're going to be talking about gas laws. This whole unit is actually going to focus on gas laws. We're going to clarify a lot of things for you over the next couple weeks. I thought it would be best to introduce some things about gases, some things about the behaviors of gases, and how different variables related to gases affect the way a particular gas may behave. Those variables that we're going to be talking about. One, pressure. Pressure is a new unit that we haven't really talked about this this year, but I'm going to talk about it more in the next frame. We're going to talk about volume. If you guys remember volume is the amount of space that a particular material takes up. In our case, we're going to be talking about the volume of gases. In our class, we typically use the base unit liters. All right, we're going to be using liters for our calculations, and you're also going to need to remember how to convert from milliliters to liters. And remember that there are that one of these equals 1,000 of these. Okay, so that's a good conversion factor for you. Moles, in our case, if you remember, moles we use to describe the amount of atoms and the amount of molecules. So in our case, we're going to be talking about the amount of molecules and amount of atoms of gas. And really, what we use this unit for in this unit is to really describe the amount of a particular gas that we have. How much gas do we have? Well, we talk about that in terms of moles. We're also going to be dealing with the unit Kelvin. And Kelvin is a measure of temperature. All the temperature calculations that we have in this unit are going to be using Kelvin as the units, but you have to remember that to get Kelvin from a particular Celsius temperature reading, you need to add 273 to that. So just make sure you remember that equation so that you can do all your Kelvin conversions. So we can go ahead and talk a little bit more about pressure. If you were to define pressure, pressure would be some force exerted over a particular area. That's what pressure actually is. And I guess the best way to explain this would be to explain something that you guys are all familiar with. How about a wonderful balloon? Yeah, a balloon given to you by your favorite clown, whatever it is. Now this balloon, you see, is filled up with molecules of gas. Molecules and atoms of gas, and they're all in there. But they're not just standing still, okay? They're not just standing still. They're actually zinging all over the place. They're bouncing all over. They're running into one another. They're hitting the sides of this balloon, okay? It's a madhouse in here. It's a huge molecular party, okay? Now, each one of those little atoms, each one of those little molecules is hitting the side of that balloon. And when it hits the side of the balloon, it exerts a force. Now, one little atom or one little molecule bouncing off the side of a balloon is really not that big a deal, okay? But remember, inside that balloon, there are trillions and trillions and trillions and trillions and trillions of molecules and atoms of gas, and each one of those is bouncing off the side of this balloon, and so collectively, as a whole, they are applying a considerable amount of pressure to the inside of that balloon. So there you go. It's sort of an explanation as to what pressure is. Now in our class, we are going to be talking about pressure in a number of different units. We are going to run into millimeters of mercury as one unit. We're going to talk about that just a little bit more later. We'll talk about pascals. Pascals are a unit of pressure. You guys might be familiar with PSI, pounds per square inch. In the United States, we use inches, square inches to describe area, and pounds. Pounds would be the amount of force that is applied over a particular square inch area. Now, mostly in this class, we're going to be talking about atmospheres as a unit of pressure. Again, ATM stands for atmospheres. And I guess the best way for me to describe this would be to draw a picture. Now, consider this. Consider this is the crust of the earth. Okay? Now, there are bunches of air molecules all over the place, okay? And gravity pulls those molecules close. And so as it turns out, there are many more molecules closer to the surface of the Earth than there are farther away. So hopefully my illustration sort of shows you that. Now here you are, right here at the bottom of this ocean of gas. Okay? And these molecules are exerting a force upon you. Now, if you were standing on the beach at sea level, you would be experiencing the pressure that is exerted by one atmosphere. One atmosphere, one of Earth's atmosphere. If you were at the top of a mountain, well, you wouldn't be feeling as much pressure. So that's why when we go up in altitude, our pressure becomes less. When we go down to the bottom of the ocean, now we not only have that column of air pushing down on us, but then we have all this mass from this water column pushing down on us. So that's why we feel water pressure. So you need to think about the fact that we are, in fact, walking at the bottom of this gigantic ocean of air molecules. So let's go ahead and move on and start talking about some of the relationships between the different variables. First, let's take gas pressure and relate it to volume of the gas. How are pressure and volume of a gas related? Well, to describe this, we always use this idea here. We have a piston, and it's a movable piston. It can go up and it can go down, okay? And here we have some gas inside of a chamber. Right now, okay, the gas is a particular volume. We'll call that volume 1, okay? And right here, this piston is pushing down, applying a particular pressure 1. Now, if we push harder, if we add more pressure, we'll call that pressure 2, then that piston's going to move down. It's going to move down. And what happens to our volume? Well, volume, now as you can see, becomes less. All right, so pressure down, less volume. Okay, so really what we see, and what you guys need to remember, is that pressure, when it goes up, the volume of the gas often goes down. Okay, so you need to remember that relationship. As pressure goes up, volume is going to go down. We can also talk about the relationship between the volume of a gas and the moles, or the amount of a gas that we have. So how are volume and the amount of gas and moles related? A perfect way for us to talk about this situation is just to think about the human lung. Remember that you start out with some number of moles of gas in your lungs, and as you inhale, you're adding more moles, right? You're adding more gas, and so as I add more gas, look what happens to my lungs. They get bigger, right? They get bigger. So here I've got N2, and that's going to add to the volume of my lungs. And so you can pretty much describe this as saying that as N, or the number of moles, goes up, then you know the volume is also going to go up. Makes a whole lot of sense, doesn't it? So now we can also talk about volume and temperature and how they're related. How is the volume of a gas and the temperature of a gas related? How does one affect the other? Okay, well, let's take, for example, these two balloons. Okay, if I was to have one balloon at 25 degrees Celsius, okay, and at a particular volume, volume 1, we can call it. If we were to take that same balloon and we were to increase the temperature to, say, 50 degrees Celsius, we would see that the volume of the gas would go up. So the relationship I want you to remember is, as temperature goes up, all right, volume of the gas also goes up. Remember that relationship. Now, I hope this helped a little bit. It's just a slight introduction into the relationships between different variables of gases: volume, pressure, the number of moles, and the temperature. How does one affect the other? This can be kind of tricky to think about these questions, so go ahead, watch this video a couple more times, and then you can go ahead and go to Moodle to take the the introductory gas quiz that's there. If you have any more questions, just come into class, get some help from Werner, DeMaria, or I. We'll definitely get you on the straight path towards success with gas laws. This is Underwood signing out. Sayonara.